Yesterday we added and subtracted radical expressions. Today we're multiplying radicals. And it's only this page of problems and notes, so this will be quick. First of all, a couple of rules. So what we have up here says the nth root of AB equals the nth root of A times the nth root of B, which means, as we've actually done many times, let's say I want to do the square root of 20. Well, what you'll see me do sometimes is I'll split 20 up into two parts, and I'll say the square root of 4 times 5. And sometimes we get that expression by a factor tree as well. This is this side of the problem. And what it says we're able to do then is split up into square root of 4 times square root of 5. And of course then we would get 2 square root of 5. So this is just telling us we can split up the factors underneath a radical. Factors are things that multiply. The second rule says that if we have them split up, and we're multiplying, we can put them together. Again, the indices are the same as well. So the square root of A times the square root of B equals the square root of A times B. Or if I have, let's say, the square root of 7 times the square root of 10, then I can multiply them under the same radical and get the square root of 70. So that's all these rules are saying. The one thing that's important is the indices need to be the same in order to multiply, and if you split them up, the indices are the same. Okay, makes sense. So let's buzz through these. Square root of 2 times square root of 6 is the square root of 12. Now it says express in simplest radical form. So in each of these you want to stop and think, can I simplify the square root of 12? And of course the answer is going to be yes, quite often. So the square root of 2 times the square root of 6 ends up being equal to 2 square root of 3. Now if you weren't sure for these numerical questions, if you did everything right, you could type this into your calculator and type this into your calculator and make sure you get the same answer. So let's keep going with our multiplication. Square root of 5a cubed times square root of 10a. Multiplying them together, we get the square root of 50a to the 4th power, because there's 3 here and there's 1 here. Well, that's definitely going to simplify. 50 is 25 times 2, and a to the 4th is that right there. Remember, we pull out perfect squares. 25 is a perfect square. And we pull out a times a is a perfect square, and another a times a, which gives me a squared on the outside. And what's left is the square root of 2. So 5a squared square root of 2. Question number 3 is a little bit different because I have a binomial. I have 2 terms raised to the 2nd power. So this means I need 2 of these multiplied together. And here we're going to end up foiling. So let's do it in that order. The firsts are 1 times 1. The outers are 1 times the square root of 3. The inners are 1 times the square root of 3. And our lasts give us the square root of 3 times the square root of 3, which is 3. Square root of 3 times the square root of 3 equals square root of 9 equals 3. So let's combine like terms. We've got 1 plus 3, that's 4. And notice we're adding like terms now. Radical 3 plus radical 3 is 2 radical 3. So that one had a little combination of today and yesterday. Number 4. Pause or rewind if you missed something. Or remember to put question marks where you have a question. You could ask me tomorrow. Cubed root of 16, cubed root of 4. So I can multiply those and get the cubed root of 64. Now I need to be concerned that 64 might contain a perfect cube. So let's check it out. It's 8 times 8, which is 4 times 2, times 4 times 2. So it's 2 times 2, times 2, times 2, times 2, times 2. We need triples to bring them out. Here's a triple. Here's a triple. And so this simplifies to 4. You can check that out on your calculator if you want. Remember, to get a cubed root, you use the math button. Number 5. Number 5 is set up for distributive property. So radical 3 times 4 is 4 radical 3. Radical 3 times radical 3, we just did up here, is 3. And we're adding. Can we combine 4 radical 3 with 3? No, we cannot. They are not like terms. So we're done. Number 6, set up for FOIL. Two times 2 minus 2 radical 7 plus 2 radical 7. And then a positive times a negative is negative. And radical 7 times radical 7 is, you shouldn't have to do this step. Radical 7 times radical 7 is just 7. So what are our like terms? Well, we've got a couple of whole numbers here. We've got 4 minus 7, negative 3. And then we've also got minus 2 radical 7 and plus 2 radical 7. And those produce 0. So those cross each other out, if you will, and my answer is negative 3. Okay, here's another FOIL. 2 times 5. 2 times radical 2. Negative radical 3 times 5 is negative 5 radical 3. And negative radical 3 times positive radical 2 is negative, multiply under those radicals, negative radical 6. So let's see, what can we combine? Does anything combine with 10? No, no, and no. All right. So does anything combine with 2 radical 2? No. Does anything combine with 5 radical 3? No. And unfortunately, nothing combines. Not unfortunately. There are no like terms. That is your answer. All right. Whoops, didn't mean to do that. I didn't mean to do that. It's fun. There we go. Number 8. We've got a 2 outside, so we're going to write this twice. Write it twice. Good advice. Now it's not a binomial this time. Binomial has two terms in it that have adding or subtracting between them. This is not a binomial. This is just 3 radical 5 times 3 radical 5. So it's the same as saying 3 times radical 5 times 3 times radical 5. So I can rearrange my terms by the commutative property. 3 times 3 is 9. Radical 5 times radical 5 is what keeps happening every time we get the same radical. Radical 5 times radical 5. Radical 7 times radical 7 was 7. Radical 3 times radical 3 was 3. So radical 5 times radical 5 is 5. So we have 9 from the 3's, and radical 5 times radical 5 is 5. And 9 times 5 is 45. Let's do another one of these, just on the side. Let's do 5 radical, 5 radical 7, all squared. So see if you can do that. 5 radical 7, all squared. Take a moment, write it down, figure it out. We're going to have 5 radical 7 times 5 radical 7. That means 5 times 5 is 25. Radical 7 times radical 7 is 7. And 25 times 7 is, get out your calculators, or think about 7 quarters. How much money would you have if you have 7 quarters? 175. Okay. I feel better that we did another one of those. Let me move that up. There we go. All right. So we get to number 9, and notice number 9 is in red. I love it. It's in red. And there's actually a not equal symbol here. So what I really want you to focus on is not looking under the radicals and saying, oh yeah, I can multiply negative 8 times negative 9 and I get positive 72. Because of course that's true. But what happens here is that the square root of negative numbers is not real. So you can see these are not real numbers. And we're talking about the set of real numbers. And because they're not real, you can't do this problem. So please just watch out for these tricky ones where you have negatives under the radical, at least until we learn what else we can do with that. Number 10. So if we have an outside value and an inside value times an outside value and an inside value, I think you saw before, we can rearrange those terms. So even looking at a simpler example of number 10, if I have 3 radical 2 times 5 radical 7, all I have to do is my outside numbers times each other, and then under my radical numbers times each other, and I'm done. So in number 10, since we're multiplying, let's take the 2 times the 3, and underneath the radical, the xy squared times xy is x squared y cubed. And now let's simplify. This means x times x and y times y times y. You still need this little help. And so an x comes out, a y comes out, and a y stays in. So there we go. 2 more, and we're done. square root of a fraction can be split up. So let's split each of these up and see what we should do. And step back from the problem every now and then, because I see some really nice things here. The first thing I see is that I have a perfect square there. So I'm going to bring that out as an x. And if I multiply across the top, then I have x, square root of x. And multiplying across the bottom, radical 3 times radical 3 is 3. There you go. And last one, number 12. Whew. 8 radical 6. Let's put it over 1 so that it looks like a fraction. Let's split up our square root of 5 with our square root of 2. And an interesting thing is going to happen here. Some of you would remember that if I'm multiplying and I have terms with the same factor in them, that I can reduce before I multiply. So let's see, you could think of 8 as 8 radical 3 radical 2, and we're multiplying it by radical 5. So I multiplied across the top and I split up radical 6. And multiplying along the bottom, I have the square root of 2. And then I have the same factor on the top as I do on the bottom. So they reduce. This is one way to do this problem. Outside numbers, I've got 8. Under my radical, I have radical 3 times radical 5. That's radical 15. Nothing in my denominator, so I am done. What else could we have done here? Well, I could have just said, I've got 8 radical 6 times radical 5. That's 8 radical 30. And 1 times radical 2 is just radical 2. And then I could have to ask, does radical 30 have a radical 2 in it? Or can I reduce the 2 and the 30? And since this is radical 2, radical 15, I can indeed reduce them and, of course, have the same answer. So there you go. You are all set. I'll see you tomorrow in class.